Today we are going to teach you about meiosis.
Meiosis is cell division in sex cells, also known as gametes.
Let's get into the video.
So you're probably wondering, what exactly is meiosis?
Like I said before, meiosis is cell division in gametes. However, it's not as simple as I make it seem.
Meiosis is a multi-step process in which one gamete divides into 4 gametes, each with 23 chromosomes, aka haploid, that are all different. For the purpose of this video and sizing, 2n will equal 6.
The cell division of the gamete begins with interphase, where the cell is growing, its DNA is replicating, and it is carrying out its basic cell functions. A gamete spends most of its life in interphase. This must happen before meiosis begins because the cell cannot replicate without replicating its DNA/chromosomes.
The cell is now ready to divide and enter the first official step of meiosis, prophase 1. Prophase 1 is where the chromosomes are condensing and the homologous chromosomes are pairing up. These homologous chromosomes begin the process of crossing over. This is where the chromosomes transfer or exchange genetic information between each other.
Next, we move into metaphase 1, where the homologous chromosomes line up in the middle of the cell or the metaphase plate and attach to the spindle fibers. As you can see, this looks different from mitosis because the chromosomes are in pairs at the metaphase plate.
Now moving on to anaphase 1. In anaphase 1, the spindle fibers pull the chromosomes toward the centrosomes on opposite poles of the cell.
Next, we have telophase 1, where the nuclear membrane forms around the chromosomes and the nuclear envelope begins to form.
Finally, in cytokinesis 1, the cells are officially split into 2 new cells. But don't get too happy because we do it all again minus interphase.
Welcome to meiosis 2. We now have 2 cells, each with 23 chromosomes, 46 chromatids, and an eager to divide. Hold on to your hats and grab a snack because we're only halfway through gamete cell division.
We begin meiosis 2 with prophase 2. Prophase 2 has less stuff going on than prophase 1. The cell no longer has to cross over or pair with the other homologous chromosomes because we already have a sister chromatid attached at the centromere. Because of this, prophase 2 is very uneventful and consisting of spindle fiber development and condensing of chromosomes.
The cell then moves on to metaphase 2, where the chromosomes line up in a single line in the middle of the metaphase plate. This contrasting the line of the pairs in metaphase 1. The spindle fibers attach.
Next we have anaphase 2, where the sister chromatids are pulled apart by the spindle fibers and brought toward the centrosomes at the opposite poles of the cells.
Moving on to telophase 2, where a nuclear membrane forms and the chromosomes and the nuclear envelopes on both cells begin to form.
Finally, for real now, we have cytokinesis 2, where the cells split apart for good.
There you have it, folks. Meiosis. We are left with 4 gamete cells, all independently assorted with different genes. That's why you look so different to your siblings.
Thank you all for watching.
Bye!